Hello, myself Professor Harish Bagare from Department of Electrical Engineering, SND College of Engineering and Research Center, Evla. I welcome all of you in a video lecture series of Basic Electrical Engineering of first year engineering. So today we are discussing about the alternating currents, basic fundamentals of the alternating currents. So in part 3, we'll discuss today how to find the RMS value analytically. So analytical methods for finding the graphical value. In last lecture, we have already found the alternating RMS value graphically. So calculation of RMS value by using analytical method. Now we will see. So we consider a sinusoidally varying alternating current as given by I is equal to Im sine of theta or I is equal to Im sine of omega t. Now consider the elementary interval of instant d theta we will only consider. Okay, and for the d theta as shown the average instantaneous value of the current in this interval we will find it out. Okay, before that the RMS value can be find out by this equation or by formula, and certain steps are there. So the first step for finding analytically the RMS value is write down the equation of an AC quantity, and here the equation for the AC quantity is I is equal to Im sine of theta, and observe its behavior. In second stage, for finding the RMS value is to take the square of the alternating current. So take the square of this equation I is equal to Im sine of theta, and its square is I square d theta or Im square sine square theta. Okay, then after that find the value, average value of a square of an alternating quantity. After that we have to find out the average value, and how to find the average value. For finding the average value, so here the average value is being found, and the average value can be found by the formula, that is it is a ratio of area of curve over one cycle of squared waveform upon length of the cycle. And after that find the square root of the average value, and that square root of the average value itself will give you the RMS value. Okay, so here we have written the equation of the alternating current I is Imax sine of theta, and take its square. So mean of the squares of the instantaneous value of the current over a half cycle now we will consider. So the length of the half cycle is pi. So the I square is equal to integration from 0 to pi I square d theta upon pi. So I square is equal to 1 upon pi integration of 0 to pi I square d theta. I square is equal to I m square sine square theta. So 1 upon pi integration 0 to pi I square sine square theta is equal to I square Im square upon pi integration 0 to pi, and sine square theta I can split like 1 minus cos of 2 theta upon 2 d theta by using the trigonometric rule. Then find out the integration of 1 minus cos of 2 theta d theta, and here you will get I square upon 2 pi. It is theta minus sine of 2 theta upon 2, and limit is 0 to pi. So after putting sorry, we will get the final answer as I square m upon 2 pi into pi, means I square m upon 2, and after the last stage is take its square root, and hence I is equal to under root of Im square upon 2 and is equal to Im upon root 2. So my RMS value, that is I RMS, is always equal to Im upon root 2, that is 0.707 Im. So you always remember RMS value is always I is equal to Im upon root 2 or 0.707 Im. If it is voltage, then it is V RMS is equal to 0.707 Vm. Now, what is the importance of the RMS value? So in case of the alternating quantities, the RMS values are used for specifying magnitudes of alternating quantities. The given values such as 230 volt, 110 volt are RMS values of alternating quantity unless and otherwise specified to be other than RMS value. So you remember that the RMS values are always expressed like this, and the household So supply whatever it is we measure at 230 volt, it is nothing but your RMS value. Now let us take one example on this topic. So calculate the RMS value, average value, form factor, peak factor of a periodic current having following values for equal time intervals, changing suddenly from one value to the next value, as here it is initially 0, then 2, then 4, 6, 8, 6, 4, 2, 0, like this. Okay, for this you have to find out the different values. So the waveform can be represented as shown in the figure. Okay, so at this at particular instant of time, the different values are being shown. First we will find out the average value of the current, and it can be given as average of all the values in 0 plus 2 plus 4 plus 6 plus 8 plus dash dash dash, right, upon 10. Okay, over a half cycle. Okay, so these are the 10 values: 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So over half cycle, it is average value is 5 ampere. Okay, we never calculate the average value for a complete cycle, because for a complete cycle the average value is 0, with a positive half cycle and negative half cycle. And the average value is only calculated for a half cycle, and the average value for this example is 5 ampere. The next is the RMS value of the current, and we know the RMS value of the current is nothing but square root of the average value, and it is square root of the squares of the instantaneous value. So it is 0 square plus 2 square plus 4 square plus 6 square plus that upon 10. So it is 5.8309. So RMS value is this one. Then form factors. Form factor we know it is the ratio of RMS value to average value, and it is 5.8309 upon 5 is equal to 1.16. Okay, similarly peak factor is maximum value upon RMS value. Maximum value is 10 here. Okay, so here the maximum value IM is 10. So it is IM is equal to 10 upon RMS value are calculated 5.8309, and my peak factor is 1.715. Next example is here. So sinusoidally varying alternating current has a RMS value of 20 ampere and periodic time of 20 milliseconds. If the waveform of this current enters into its positive half cycle at time t is equal to 0, find the instantaneous value of the current at t1 is equal to 6 milliseconds and t2 is equal to 12 milliseconds. So we have to find out simply the instantaneous value at time t is equal to 6 seconds and time t is equal to 12 milliseconds. So for that, RMS value is given as 20 ampere and time period t is given as 20 millisecond periodic time. There now we know IM is equal to root 2 IRMS. So IM is equal to root 2 IRMS. RMS value is given, it is 20 ampere. So my IM is 28.2842. Now frequency, it is time period is given. Time period is what is given? Time period t 20 millisecond. So 1 upon t. So time my frequency is 1 upon 20 millisecond. So that's why it is 50 hertz. So omega is equal to 2 pi f angular frequency. It is 314.1.92 radian per second. Now hence equation for the current is I is equal to Im sin of omega t. So Im I have calculated as 28.28. Sin of omega t, omega I have calculated, that is 314.1592 t. At time t1, t is equal to 6 milliseconds, I have to find I. So put time t here, t is equal to 6 milliseconds and find out the value. Okay, so you will get I is equal to as 26.899. Next time, put the time t here 12 milliseconds and solve this, and you will get I will minus 16.625. Okay, and for calculating this, you have to use only radian mode. So thank you. This is for today. Next time we will discuss the next topic. Till then, goodbye.